In Lightwave 3D, you can move realistic three-dimensional objects in almost unlimited color and detail. Not only can you move the objects, but multiple light sources as well, along with the point from which the action is viewed, the camera, and there are virtually no limits to the Lightwave system. One of the most powerful features of Lightwave is the ability to control and fine-tune the surfaces of your objects. For example, take this apple. With Lightwave, we can change its color. We can set its reflectivity. We can give the surface a texture, or give it bumps. We can make the apple wooden or stone. We can wrap or map a picture onto its surface. And by varying the lighting, we can vary the outcome. Hello, my name is David Evgikas, and for the next 2 hours we'll be covering techniques and tips for obtaining results like these. Some of the other topics we'll be covering will be beginning with an idea and the creative process, creating objects in Lightwave Modeler, assigning surfaces and textures, and creating a keyframe animation. You will also be able to use the second half of this tape as a reference guide for surfaces and settings. Instead of guessing what a particular setting will look like and then waiting for it to render, simply view the second part of this tape, look at the surfaces you desire, and copy the settings given. This alone can save vast amounts of time. First, let's talk about some of the equipment that will make creating pictures and animations in Lightwave quicker and easier. The necessary equipment is an Amiga 2000 or 2500 computer and its an accompanying RGB monitor, 5 megabytes of RAM, including the Fat Agnes chip, a hard disk, the video toaster itself, and a composite video monitor. Optional equipment includes extra RAM, 7 or 8 megabytes, a large hard disk, 80 megabytes or better, an accelerator board, a single frame controller, a frame-accurate tape deck, and a color video camera or a camcorder combination. Extra RAM will allow you to load more objects into your scene. It will allow your scenes to contain more frames, and it will allow you to load in larger picture files for backgrounds, foregrounds, or object surface maps. A larger hard disk will allow you to save more pictures, objects, and scenes to disk. An accelerator board will drastically cut rendering time. Consider this. An object that takes 7 minutes and 4 seconds to render on a machine with a 16 MHz 68020 board, one of the slower of today's accelerator boards, takes 1 hour and 13 minutes on a stock 2000. Now consider this. Let's say that you're going to create a simple 10-second animation. Since video uses 30 frames for a finished second, your 10-second animation would contain 300 frames. Now at 1 hour and 13 minutes per frame, that's 365 hours in rendering time, more than 15 days that your computer is unusable. Now with the addition of even a low-end accelerator board, you would render that same animation in only 35 hours. Now if you do computer graphics and animation for a living, you've just saved yourself almost 13 days of valuable computing time, not to mention wear and tear on your video equipment. That time savings translates into bottom line dollars real quickly and justifies the money spent. We've included a list of spot prices on accelerators to give you an idea of the cost involved. As of this taping, the only way to play back your animations in their original format is with the aid of a single frame controller and frame-accurate tape deck. These devices, when hooked to your computer, will accurately render 1 frame at a time, which can then later be played back at full speed. Now the toaster currently supports 3 popular single-frame controllers: BCD 5000 from BCD Associates, Minivas from Lion Lamb, and the VLAN controller from Video Media. Finally, you may wish to obtain a color video camera for digitizing images that can later be mapped on to your objects. Having said all this, let's begin our look at NewTek's Lightwave 3D. Lightwave was written by Alan Hastings. Alan wrote the original Videoscape 3D back in the early years of the Amiga. If you are familiar with this program and its sister program Modeler 3D, then so much the better. while Lightwave 3D is light years ahead of videoscaping capabilities. A general knowledge of 3D will help you use this program. Believe it or not, the most time-consuming part of creating a picture or animation with Lightwave may very well be coming up with the idea. Take a look at some of these high-end animations and see if they stir your imagination. The reason we show you these is to get rid of any preconceived limitations that you might force upon yourself. Think big, let your creativity flow. Flying logos are what most people think of when they hear computer animated graphics. So let's start there. In the first hour of this tape, we'll go through the steps used in creating and animating a company logo. The Energy Corporation came to us with this logo and 4 color pictures and asked for us to create a computer animated 10-second commercial. Before we could animate, we had to transform their 2D logo into 3D. This is done in Modeler, but before we could actually get into the program, we had to plot it out on graph paper. We placed the 2D logo over a backlight. Then we laid graph paper over the logo. We are then able to plot each important angle with a pencil. When we finished, the graph paper looked like this. Now, fortunately for us, the text in their logo is the same font style of the text that comes with the Lightwave 3D package, so we didn't have to create that. Now that we have our design laid out on graph paper, the next step was to get into Modeler and actually create the 3D logo. We're lucky in this instance because most of this 3D logo is a circular shape, so we need to start there and create a large disk. I see from my graph paper that it measures 4 squares by 4 squares. I'm going to translate that into meters and make my disk 4 meters by 4 meters. I do this by selecting Disk under the Objects menu, and with my mouse pulling out a square that measures 4 by 4. I don't want the logo to be flat, so I'll also extrude the Z-axis by about a meter. When I'm satisfied that I have everything right, I click on the Make button, and that makes my disk. One thing to point out here is that we're using 16 points to make up our circle. Now that's fine for most applications, but this needed to be really nice. So I went into the numeric function and took out 16 under segments and put in 64. Now I've zoomed into my circle. It's time to lay in the center points or angles of my logo. I've measured on my graph paper and I see that each point is 8 units apart. That'll be 8 centimeters in Modeler. So the first thing I do is line up my crosshair using the numeric output on the bottom left of the screen. I go down 8 centimeters and click my mouse button and lay down a point. Then going up 2 centimeters, I lay down another point. Again, over 8 centimeters, laying down a point, down, laying down a point, and I continue this until all points are laid for the first part of my logo. Now that all the points are laid down for the top half of my logo, I need to connect those points into a polygon. I do this by one highlighting each point in order along the edge of my circle, then along the inner angles of the circle that I've just created. When each point is highlighted, I go to the Make button, and that's the first part of my logo. So now the top half of the logo is done, and we repeat the process for each of the next 4 parts of the logo. When we're finished, our logo looks like this. Now onto the text. The text was easy, but we still needed to bring in each letter together and make it one object. And this is how we did that. At the top right-hand screen of the Modeler program, there are 8 small blocks, each one representing a different layer. In the word Entergy, there are 7 letters. So we load each letter into a separate layer. After the letters are loaded into their individual layers, we space them accordingly so they don't bump into each other. Now we're ready to save all the letters as one object. To do this, we hold down the Shift key and click on each layer successively until we've had all 7 letters together. Now we go to Disk and Save, type in the name Entergy, and return. That will save all 7 layers as one object. Now that's it. Of course, these weren't very difficult objects, but we've created them and now we're ready to do our animation. So we exit Modeler, get back into Lightwave. Now we've decided the particular type of animating effect we're going to do. It's actually going to require 2 parts. The first part is going to have the logo rising slowly out of the water and turning to face the audience. The logo will stay there right above the water for a second. Then remember the 4 pictures we showed you at the beginning? Each one of those is going to zoom in to a different quadrant of this logo. We'll do that with image mapping. Now after that happens, the logo will slowly turn 360 degrees to reveal the solid color red again. After that happens, the logo zooms out through the crowd. Now to prepare for this, we'll use our color video camera and digitize each one of these pictures using the frame grabbing capabilities of the toaster into an image that Lightwave can see. Once those images are done, we'll be able to wrap those or map them onto the surface of our logo. Now we have an interesting problem here. Since we want our logo to appear to rise out of water, and I don't want to have to generate the water in Lightwave, what we're going to do is superimpose it over video of real running water. Now that's not too much of a problem, but what we have to do is make the logo appear as it's rising out of something. To do that, we're going to draw a black flat plane like ground and have the logo rise out of that. So we need 3 particular items in this animation: the flat black plane, the text that says Entergy, and the round red logo. We're going to go ahead and load those up into Lightwave right now. Now in the interest of time, we've gone ahead and set the number of frames to 120. This will give us 4 seconds of animation for this first part. We've loaded in our 3 objects: the round Entergy logo, the word Entergy, and a plane, a black plane. Now we're going to go ahead and do some work inside Lightwave. The first thing we have to do is we have to link the word Entergy with the red ball Entergy logo. And that's called setting a parent object. And we do that here by selecting our objects, in this case Entergy logo 2, which is what we've given the name of the text. And I'm going to click the Set Parent button and cursor around until I find Entergy logo and hit OK. Now I can move the word Entergy independently, but every time I move the Entergy logo, the red ball, the word will follow it around screen. Now watch what I mean here. We're going to take a look at the screen, and I'm going to move here the red Entergy ball around, and you notice how the text follows it. Now I'm going to change my object to the text, Entergy text. I'm going to move it around. The ball stays there, but I can move that text any way I want to. When I switch back to the red ball and move it, again, the word Entergy follows it around screen. Very handy in this particular case. Okay, now that we've got our parent object set, we have to set our keyframes. You probably know from working with Lightwave that Lightwave will figure out how to draw the frames in between the keyframes you've set. Now this motion we're going to do is pretty simple. It's going to have Entergy and the word Entergy sitting flat at the bottom of the screen, and over 4 seconds it's going to rise out and turn towards the audience. So all we really have to do is set the beginning position or keyframe at 0, and the ending position, keyframe in this case, at number 120, and then the computer will figure out the rest. So let's go ahead and set our keyframes now, and then we'll test the motion out. Okay, what I've done here, as you can see, is I've moved the word Entergy, placed it right underneath the ball. It's highlighted. I'm going to go to Create Keyframe on 0 and create a keyframe for the selected item, in this case the word Entergy. Now that locks it to my red ball no matter where I go. I'm looking at the XY view mode, so I can see the plane of water. That's important because I want to start this animation with the logo underneath the plane of water. The next thing I do is select the round ball object called Entergy logo, and I need to tilt that to where it can be under the water. I'm going to do that by hitting rotate and moving my mouse up to get it flat towards us. Then move using my right mouse button, because I want to go down, and move it down like that. That's it. That's how I want to start. So I'm going to hit keyframe for selected items on 0. OK. And now all I need to do is pick out my ending frame. For that, I need to rotate the logo back the way it was and move it straight up out of the water and create a keyframe there on 120. OK. And that's it. So we should be ready to test out the movement now with Make Preview, and we'll go ahead and do that now. We'll come back to you when it's through. I didn't quite like the effect that this has. It's almost what I want, but not quite, because the object comes out of the water and spins in one even motion. What I'm going to do is I'm going to break it down. I'm going to give it 1 second to come completely out of the water, and then 3 seconds to turn to the audience. Fortunately, with Lightwave, that's real easy to do. All we're going to do is position our object right above the water and set a keyframe at frame 30 and let it figure out the rest. Okay, we're going to do that now, and we'll come back to you with a wireframe animation of that when it's done cooking. Okay, now we like the way that one turns out. That's what we had more in mind. And you saw how simple it was to just add in a keyframe, redo a wireframe, and it was done. We're going to go with that. Now we have another part of this animation to do. This one, now that the red logo is up and facing the audience, what happens now is over a couple of seconds it spins around 360 degrees. And it's a little bit more complicated than even that, because we'll have those 4-color pictures that we showed you at the beginning of the tape kind of zoom into different quadrants of the red circle. They'll stay there for a second, and then it'll spin around, and when it comes back around, it's red again.